My name is Ayda Nadim and I have chosen problem statement 2 for Gen AI Academy APAC edition. My project is titled Drone Swarm, Telemetry and Collision Engine. This system could be practically used by disaster response coordinators where they are operating a massive fleet of 5,000 plus autonomous drones in a confined space. This project could also be used for wildlife and forest conservation, where anti-poaching patrols and forestry department protect local ecosystem and national parks from illegal activities and wildfires by deploying wide area surveillance swarms operating over remote wildlife reserves. Another application could be smart agriculture and precision farming, where autonomous drone swarms are deployed to spray crops and monitor soil health. In this scenario, the data dependent bottleneck is that the standard CPU architecture cannot handle high frequency spatial mathematics, that is, calculating the distance between 5,000 moving objects simultaneously fast enough. If the CPU takes too long to process the data, the drones have already moved and the data is obsolete. On our page, we can see a clean and structured dashboard. The data from several drones such as X, Y, Z coordinates, battery and temperature are used by this sophisticated system to ingest, clean, analyze and model high-frequency data with minimum latency. Here, we will be dynamically mapping the drones to avoid high-traffic choke points and recall the units with failing batteries before they drop. Their color represents the temperature of the drones. The darker the dots, the higher the temperature of the drones. The dots also represent the battery percentage of that particular drone. The smaller the diameter of these dots, the lower the battery. The scale for temperature and battery percentage is also given at the bottom of the map for your reference. On the left of the screen, you will be able to see the details about the processor, acceleration, and latency. Currently, this app is using my local CPU, which is causing a lot of latency and decreasing the overall real-time performance. You can see that the number of critical risks of collision is also very high. If I increase the number of drones in the system, the latency increases and the performance worsens, increasing the number of risks. Using this button, we can switch to NVIDIA's Cloud GPU with CUDA or CUDF acceleration. We can see how the latency and the number of critical risks reduce significantly. This would reduce the risk of collision and provide real-time analysis despite increasing the number of drones in the system. In addition to the reduced latency, we have added a Swarm Commander AI, an AI chatbot that analyzes and answers your question real time. We can ask anything regarding drones. For example, how many drones are there in the system? Here it correctly answered 5,000 drones. If I ask how many drones have less than 85% battery, the AI chatbot analyzes the data and generates the answers. It answers 1,664 drones. This was my global drone swarm telemetry and collision engine. Thank you.